the left-hand side, because now we're under acquisition. And then there's all of these buttons here. We'll go over those in a second, because I want to go for the next icon, which is real-time batch. So if I click this, this is our batch table now. So this is what we create when we want to run our standards and our samples. So exactly. The next icon is report format. There's really no need. The report, yeah, there's no need to mess with reports while you're in real-time analysis, because you want to analyze your data and post run to make sure everything's good before you print out any results or save SPS. Exactly. So the next one's calibration curve. This is the same as report format. There's really no need to click this button now. We'll do this in post run when we get to that point. Maintenance guide. Said, oh, it's the exact same maintenance guide. Okay. Perfect. So yeah, that maintenance guide button pulls this back up. And then batch editor. I don't suggest using batch editor. I suggest using real-time batch. Okay. So now that we went over the main icons you guys will work with the most, I'm going to go back to the data acquisition tab, because now I'm going to show you guys how to either A, create a brand new method, or B, how to open up a method that's already been created. So, yeah. And it's the exact same as over there. So if you want to create a brand new method, when you're in the data acquisition tab, you'll click File and then New Method File. That pulls up brand new method where you can input parameters. Yes, exactly. But I'm going to click Open Method File, and let's see. Just want to look at something real quick. Okay. Okay. There we are. Okay. Cool. All right. So just like over there, like this is gonna be new for y'all too, but to find your method data files, your chromatogram data files, any type of important and relevant data files, you'll find it under, if I click the file folder and I go to the C drive, there's lab solutions, and there's data, and then here you'll find either, you know, a folder that y'all create and all your names and save your projects to, or right now we just have project one. So in project one, we have 3 method files and one batch table file, and then 1 chromatogram data file. So just wanted to show you where to go in the computer to see where all of your information is saved to. So if you guys create your own specific folders, like I said, the method that you use to run your samples, move that to your specific folder. So whenever you do that, then all of your chromatogram data files and the rest of your data files should save to that specific folder that the method is in. So I'm going to close out of this. I just want to show you guys where everything is saved to. What I'm going to do first, though, is open up this method that we used to... Okay. Okay, cool. Download.
What's the name of the POD file that you're still making?
I didn't share it to the church.
Oh, okay. Well, not right now, but do it with everything. Put it on your phone.
Cool. Okay. So this is what's a little bit different is that whenever I open up this method file, that second window doesn't pop up like it does over there and over here. Yeah. So after you open up a method file that has the new instrument parameters on, in that method, you have to click this button right here that says download. Shoots it all to the instrument. So even though I clicked it, we see that specifically, so our, yeah, but our air and hydrogen flow for the FID are not peaking on. The reason over here. Let's go right on there. It should be on.
It's okay. Yeah.
Please stop.
Yes. So I what?
So yeah, we see the FID is for the FID, the air and the helium is still yellow.
They project or you know.
So we need to go over here, make sure our markup is FID. Look back here. So actually turn it on. Watch what it's one. From there, we can apply the condition. Turn on. So at this point, so here at the top, that was that playing. No, it is. Down here, and have this. Right? And then now, over here in the software, the FID airflow is no longer yellow. It's at 200. And our hydrogen flow is at 32. Cool.
For the area.
Yes, just for those two items. But there's still more yellow stuff that we see on the screen. It's because what is still yellow is still not reached its set point. Yeah, so over here on the right-hand side, this is just display information. This information is also seen over here. I just like it being in two places just in case. So we're waiting for the FID to get up to 280. Okay. We're waiting for, let's see, is a column of them coming up? Okay, yeah. Column of it is slowly coming up to temperature, so that's good. The injection port for the front auto sampler to the FID is up to temperature 250.3. We have, so now the only thing it's really waiting on is just the column temperature, the capillary column and the column button to come up to 170 Celsius. So once that column temperature reaches 170, then we should no longer see yellow, and then you should see that yellow light green at that point. So once that turns green, then you wait, like I said, anywhere from 30 minutes to an hour, more or less probably about 45 minutes of equilibrating. So this is now considered equilibrating. Yeah. Or sorry, once it turns green, it's considered equilibrating. Yeah. You don't have to manually turn the pump on. You know, since we downloaded the method, that method.
It will turn on after all the parameters reach the spot, right? Or no?
It's technically all of the parameters are already at that set point except for the column. Yeah, the column temperature. But yeah,
So the back, does it have any information?
yes. So let's see. Yeah, so line 2 is the TCD. Yeah. So yeah, like I said, it's still slowly coming up to temp. Our TCD is slowly coming up to temperature as well. Once the TCD reaches its set temperature at 200 Celsius, that's the temperature we use to run our samples. Once after it reaches 200, then we can go back to the front panel, turn the current back to what it needs to be set to. Yeah. So let me. Now, with that being said, this method specifically is just for us using the FID. So this method, you have to input in the parameters for line 2 for the TCD, mainly to make sure that our temperatures for our injection ports, the temperature for the column, and the temperature for the detector is in a close range of the temperatures for our FID injection port, column, oven, and detector. The reason being is because the FID injection port and the TCD injection port are so close together that if we tell the software that the TCD injection port should be at 100, but the FID injection port's at 200, so much heat is coming off of the injection port set to 200, where that 100 Celsius of the second injection port can't stay at 100. It'll want to rise. That's why you kind of want those to match. Same for the column oven, and the same for the detectors. Yeah. Okay. So once, like I said, once our column reaches temperature, and then more importantly, once our TCD reaches the 200 Celsius, we could then go back to the front panel and turn it on. We may throw an air thing since it's not a but turn it on. Keep in mind, not change the current until that just set temperature.
Okay. And